Welcome back, lesson 2.1. This is the third video, part C, and in this video we're going to talk about a very, very important topic or theorem in calculus that will most likely pop up on the AP exam multiple times. It is the intermediate value theorem, abbreviated the IVT. So let's go ahead, let's look at what the IVT says, and then look at some applications about how you can apply it. So the intermediate value theorem, again abbreviated the IVT, and what the IVT says is that if f is continuous on the closed interval a to b, then there exists a k value between f of a and f of b. Okay, this is the second condition. So if it's continuous on the closed interval and k is between f of a and f of b, then there has to exist at least one x value, c, between a and b such that f of c is equal to k. Okay, and this is kind of a duh kind of moment, but let's look at this. So this is saying that, again, if the function's continuous between a and b, okay, part one, then there has to exist, k is between f of a and f of b, then there has to exist a c value such that f of c is equal to k. Okay, which would be in between these two values. All right, so let's go ahead, let's look at these examples. Number 9, it says, does the IVT guarantee a c value on the given interval? Okay, so we're given a function here, f of x, okay, which is x squared minus x, and we're given a c value, okay, which equals to 12. So in this case, 12 is going to play our k value, our output, which should be between the outputs of f of a and f of b. So the first thing that we want to do, we have to state that f of x is continuous, or determine, is it continuous on this interval. And since f of x is a polynomial, okay, polynomials are continuous everywhere. So what we're going to say here is we will say that f of x is continuous on our interval 0 to 5. Okay, that's condition 1. Condition 2, we need to make sure that 12, right, is 12 between f of a and f of b. Is it between them, right? Because that's our second condition here. Okay, so what we'll do is we'll calculate f of a, which is 0. So I plug in 0 squared. Let me just make sure it's minus 0, which is 0. And we'll evaluate f of b, which is 5. So we have 5 squared, take away 5, which is 20. And we'll just state this, right? So f of 0 is less than 12, which is less than f of, I almost wrote 20. F of 5. Okay, so condition 2 is met, right? 12 lives between those two values. So what is our conclusion? Well, since it's continuous on the interval and our k values between f of a and f of b, then the IVT does guarantee it. So that was the question. Let's make sure we always answer the question, does the IVT guarantee a c value on that given interval? Well, the answer is yes. We can say that the IVT, the intermediate value theorem, guarantees a c value in 0 to 5 such that f of c is equal to 12. Okay, And there you have it. That's what we wanted to determine. Okay, so example B, here it says g of x is equal to x squared minus 4 over x minus 2. And since this is a rational function, remember rational functions, we have to be aware that our denominator here does not go to 0. Okay, so what we're going to do, we are going to factor this. Okay, so this gives us x minus 2, x plus 2 over x minus 2, and we cancel out the x minus 2 factor. Now, when you cancel out x minus 2, what you get is you get a whole at 2. A whole. This is a discontinuity, right? Not continuous. Now, where does this whole exist? Well, it's at 2, and where is 2? Smack dab in the middle of our interval, right? So what we can say is, we can say, since g of x is not continuous on the interval 0 to 3, inclusive, the IVT does not apply. Can't guarantee anything because we have a hole there. Okay? So, if your first condition fails, then the IVT doesn't apply. Okay, so let's look at question number 10. 10 says, find the C value in example 9a. So I want to go back over here. Okay, so here's our function in 9a, and we were told that f of c is equal to 12. So what we want to do is we want to solve for c. So I'm going to calculate, okay, f of c, and when I plug in c, we get c squared minus c, and remember that f of c is equal to 12. Okay, so solve. So when I go ahead and solve for c, we get c squared minus c minus 12 is equal to 0. We'll factor. So I keep wanting to write x. It's not x, it's c. So c minus 4, c4. Okay, times c plus 3 is equal to 0, producing two c value solutions. C is either 4 or c is equal to negative 3. Okay. But in this example, right, 9a, what interval were we looking at? 0 to 5. So which of these two values, applies to this problem? Well, it's definitely not negative 3 because negative 3 isn't in the interval 0 to 5. So C value, right, must be 4, okay, because C was a part of the set 0 to 5. So here's our answer. C is equal to 4. All right. So in this video, we talked about the intermediate value theorem. Huge idea in calculus. Definitely going to show up on the AP exam, so make sure you're familiar with the IVT. All right, thank you. Have a good day.